Welcome back, young people. Today we are going to be talking a little bit about this concept of a mole that's brand new to us. If you're in my 6th period class, you're going to need to stop at the first slide and do your warm-up for Tuesday. I know that you weren't in the class because I was not here. Thank you so much for being so good over in Mr. Thrasher's classroom. But please make sure that you stop this at this first slide. Stop the video at the first slide, write it down, try to answer it, and then you'll get more information as you go. Okay? Thank you very much. So here is the warm-up that 6th period needs to write down. Go ahead and please stop at this slide and try to answer it to the best of your ability based upon what you know or what you can research about this, because it does relate to something that we're getting ready to talk about. Okay, so I'm going to give you a few seconds. Okay, that should have given you plenty of time to stop that slide and look at it and get that written down. So here we go. So words that mean numbers, that's what we're talking about today. We're talking about words that mean numbers for a very good reason, because words that mean numbers are really important to us. For example, we know that a dozen, we can have a dozen cupcakes as we see here in the slide. We can have a dozen cookies as we see here. You can see that there are a dozen cookies there. Sorry about that noise, just getting an email. So we know what? We know that a dozen means there are 12 of something. So anytime we see the word dozen, we know that there are 12. Donuts come in dozens. Pencils come in dozens. Lots of things come in dozens, and we completely and totally understand that. Here, let me click off on myself so you can see all the slide. So what's another word that means numbers? Well, another word that means numbers is a ream. Well, I use reams all the time. As a matter of fact, that would be a ream of paper. And a ream of paper means that I have 500 sheets of paper. So you can see the box that says Flynn on it right there in the slide. That box contains 10 reams. So how many pieces of paper are in that box? And you'll tell me, yeah, 5,000. So, you already know how to figure out how to use that as a conversion factor. And that's what we're going to be working on a little bit later. Another word that means number is gross. This is a gross of pencils. You can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes of pencils. And each of those boxes contains 12. So it's 12 times 12 or 144. The thing that you guys most often buy in grosses are bottle rockets at 4th of July time. Bottle rockets only come in by gross. They come in dozens, and you can get a dozen dozens. That's what a gross is. So there's another word that means a number, and that's the mole. And so we're going to get to that. So let's just review. A dozen is equal to 12. A gross is equal to 144. A ream is equal to 500. So one mole is also equal to a number, but it's equal to this number. Now the problem that you're going to have with this number is that it's very, very large. This is a very large number. But why is it very large? Well, it's very large because we're talking about atoms and molecules. We're talking about things that we cannot see with our naked eye or with a microscope. So if we cannot see them with our naked eye or with the microscope, then we have to have a large number of them to be able to make up this thing called a mole that we can see and use and deal with. So that's why it's such a large number. So don't be fooled by the number. It's the same thing as dozen, gross, or ream. You just have to remember that there's a different number that's very large. And we use scientific notation because the number is very, very large. Okay? So it's also known as Avogadros number. Now, if you can say the word avocado, you can say the word Avogadro. Change the ka to a ga and change the do to a dro, and you've got Avogadros number. Now, this number was not actually developed by Amadeo Avogadro. It was actually developed later on, but it was given credit to Amadeo Avogadro by using his name because he was the first one who started coming up with this idea that there has to be some sort of way to equilibrate or to make things so that it's easier to understand them, and using a numeric quantity. So he was looking at quantities and he was looking at amounts, and he was the first guy who started working on that. So representative particles. Now this is where we come down to it. So representative particles, which are, if we go back a couple slides, hang on, we go back here. I forgot a word here. This should be particles. Okay, the word particles should be with that. So we need to define what the word particle means. So that's what we're getting ready to do. What is a representative particle in science? So it depends on the type of matter. So we have different names for the type of particle. All have the same relationship to a mole. They are all equal to 6.02 times 10 to the 23rd. 1 mole of any particle is equal to 6.02 times 10 to the 23rd. So here we go. It's similar to the relationship of 2 dozens of things. So if we look at it, a dozen donuts is 12 donuts. A dozen pencils is 12 pencils. A dozen bolts are 12 bolts. So a mole of aluminum is 6.02 times 10 to the 23rd atoms. A mole of sodium chloride is 6.02 times 10 to the 23rd formula units. And a mole of sucrose is 6.02 times 10 to the 23rd molecules. So we can see pretty clearly that it's almost exactly the same as dozen. We're using the same number. We have different words that are going along with them, but those different words, these words at the end, this one right here, this one right here, and this one right here, those words are the type of particle. So this next slide tells you about particles. So if we have an element, the particle is called an atom. If we have a covalent compound, the particle is called a molecule. If we have an ionic compound, the particle is called a formula unit. So those are some of the things that we need to be able to remember about particles and moles, because 1 mole of anything is equal to 6.02 times 10 to the 23rd atoms of anything. Okay, we're going to stop.